Let's talk about nested intervals. Let's talk about the nested sequence of intervals. When we are talking about nested intervals, essentially they are a sequence of intervals such that, now intervals, I'm denoting these intervals as in your natural numbers, so greater than or equal to 1, so I1, I2, I3, in such a manner that I1 is, that I2 is contained in I1, and I3 is contained in I2, I4 is contained in I3, and so on and so forth. So In will be contained in In minus 1, and n plus 1 is contained in In. So this is a decreasing sequence of intervals. So what will it look like? Let's just, on a line, let's just try to figure out what these nested intervals will look like. So we are talking about In is contained this is I1, say this is I1, okay. We are saying that I2 is contained in I1, okay, this is I2, okay, this complete thing is I2. Now we're saying I3 is contained in I2, I4 is contained in I3, I5 is contained in I4, and so on and so forth. Okay, so it looks like that when we will look at the intersection of all these, there would be a certain point, a point interval probably, you know, it will keep on decreasing to a point interval, okay, and there would be, say, one point which would be contained in all these intervals, which will be common in all these intervals. So what are we trying to say? We're trying to say that this portion is common in I1 and I2. This portion is common in I1, I2 and I3, and so on and so forth. But I will just give you an example that not all nested sequences of intervals have a common point. And a very famous example for that is, let's take In as an open interval 0 and 1 by n, 0 to 1 by n, open interval 0 to 1 by n. Then what will happen if In is equal to the open interval 0 to 1 by n? The intersection of all these In's, n of course greater than or equal to 1, will be phi. You will not get anything in common. Why? Let's just see it diagrammatically. Why will that happen? It's an open interval, arbitrary open interval. So 0 to 1, when we put n equals to 1, so we have 0 to 1 open interval. N equals to 2, we have 0 to half, okay, half, and then 0 to 1 by 3, and so on and so forth. It will keep on decreasing here. But what is happening? The intersection is phi. The intersection is phi because these are open intervals. And the point 0 is not there in the intersection. The point 0 is not there in the intersection because it's an open interval, because 0, 1 by n is an open interval. Okay. Now, let me also prove it. Let's do a formal proof of what we are actually trying to depict. So, for example, okay, let us suppose there does exist in X some real number X such that X belongs to In for all n greater than or equal to 1, okay, for all n greater than or equal to 1, okay. Suppose we have something in common, basically, that's what we are trying to say. Then it will be something like, you have an X, this is 0, 1 by n will be anywhere, and say this is X. Now, but what do you think we can use here? Which property? Archimedean property. Archimedean property. According to Archimedean property, what do we know about natural numbers? N naught belonging to n, there exists an n naught belonging to n such that 1 by n naught is between this real number 0 and x, okay, between real number 0 and x. And what will this actually tell me? This tells me that x does not belong to the interval 0 and 1 upon n naught, because x is greater than 1 by n naught. So it does not belong to the open interval 0 to n naught. Now, because x belongs to 0 and 1 by n, what we this was our assumption for any n greater than or equal to 1. So our assumption is wrong. Therefore, we have a contradiction. So our assumption is false. Our assumption is false. So therefore, we cannot have any common point. n greater than or equal to 1 equals to 5.